Okay, so hang on. I have to give you another trick. So this is the trick for converting decimals to fractions.
Yeah, it's a calculator, man. It's a calculator.
No, decimals to fractions, not fractions to decimals.
Yeah, mine does that.
Oh, okay, fine.
Oh.
Anyway, it's a cool trick. Shut up. So, suppose I wanted to convert like 0.33 repeating to a fraction. You guys know this is a third, right? Okay, so let me show you why this is the third. So, I think probably we could look at this as a geometric series. Yeah, so let me think about just this part here. What's the 0.3 mean?
3/10.
That means there's 3/10, right? And then the next 3 means that there's 3/100. And the next 3 means that there's
3,000.
3,000. And so on, right? Okay. If you want to see an elementary school teacher tear their hair out, tell a child about this, and then ask the child why, if you're adding infinitely many things, it comes out to a number, and then don't tell them. They'll go ask their teacher, and they'll pull their hair out over this. It's fairly entertaining. So, how do I get this to sum geometrically? Like, what's the geometric sequence happening here?
The denominator is multiplied by 10.
Yeah, okay, so think about this as, this is 3 times a 10 plus 100 plus
1,000 plus
1,000
10,000.
plus, and so forth, right? And then we have to use our formula for r plus r squared plus r cubed plus, and so forth, right?
Yeah.
Okay, so I'm going to call this s, right?
Call it something, then make things cancel.
Yep, so how do I make things cancel here?
Multiply by a negative 1/10.
Yeah, good. In that example, I'm going to multiply by negative a tenth. Here, I'm just going to multiply by negative r, right?
Okay.
So negative rs is going to be negative r squared, negative r cubed, and so on, right? Those will all cancel. And so I'll get s minus rs is r. So what's s?
This is 1 minus r.
Under r. Perfect. So on this guy, right? This whole business here becomes what? R. Yeah, r is a 10, right? And so this becomes
1 minus a 10.
1/10 divided by 1 minus a 10, right?
Yeah.
Okay, see that? What's up?
Where does the 1 minus r come from?
The 1 minus r comes from me factoring an s into this piece. That's probably the toughest part for most of you guys to see, right? You just have to remember that you're going to factor an s out. So you call the sum something, multiply and then subtract in such a way that everything cancels, and then factor the sum out on the left-hand side. So what's this boil down to? What's 1 minus the 10?
9 over 10, or 1/10 minus, or divided by 9.
So this is 1/10 divided by
9
9/10, which is 1 over 9.
Yeah.
So you have 3 times 1 over 9, which is 30. Okay.
Why is 0.9 repeating 1?
Good. Perfect. What an excellent question.
is 0.9.
Why is 0.9 repeating actually equal to 1? So there's a bunch of thoughts, but since we just learned this trick, we may as well learn this one. So we have 0.9 repeating, right? Which is 9 times a tenth plus 100th plus 1,000 and so forth, right? Yes? And we just said that this chunk here converges to a 9. So you get 9 times a 9, which is 1. Yeah, this is kind of opposite your intuition, right?
Yeah, because does that mean if you did 1 over 1, you still get 1? You don't get 0.99999, like if you divide in your calculator. So you're saying
Yeah,
9
but they're the same number.
0.9 repeating.
Yeah, what I mean
the
is
same
this.
as-
0.9 repeating is actually the same number as 1.
Put it in your calculator.
I just did it. I know. It fucking blew my head off.
Cool? So this is actually a kind of a weird thing, because normally we think about decimal expansions as being unique, right? But they're not. They're only unique up to this problem. Cool? Your head twisted off, Jim?
Yeah.
Okay, so how about this one? What's 0.19 with the 9 repeating then?
0.11.
This is 0.2.
0.2. Is it just
Like
rounding?
this
or-
whole thing just belongs in the next spot as a whole that thing.
That's just your calculator rounding then, right?
No, it's not rounding up. It's literally the same thing. Yeah, you know how critiquey I am of rounding. This is not rounding. This is actually a hard equals. Those are actually the same number.
Is there like a limit kind of thing that you can put this in?
Yeah. So you could look at this. This is the limit as n tends to infinity, right? Of the sum from I is 1 to n of 9 times 1 over 10 to the I.
I really want to screw some people with this.
And this is, yeah. So there's another easier way to see this.
You can't call it 1 though sometimes.
What?
Which is, sometimes it's like you know when like bad things happen at 1, so you have to like when you're testing limits and you're like plugging things in, and you have to get closer and closer. It's like before you actually do derivatives. It's like
Oh, yeah. So,
you can't call it 1.
So-
because it's not.
yeah, this number is actually 1.
Hmm.
But if you stop, right, if you truncate at any point, then it's not actually 1. You guys see that? If you just do 0.9 and then you write 1,000 nines,
It's not 1.
that's not 1.
It's 9.
That's a little bit smaller. This is the thing that's all nines the whole way down.
Mhm.
Guys cool with that?
Nice.
Don't be. It's okay. So there is an easier way to see this, which is if you call x 0.9 repeating, right?
X is 1.
Yeah, so x should be 1, right?
Yeah.
So the other way to see this is just to multiply this by 10. You get 10x, which is 9.9 repeating, right? You guys see that?
So that's just 9.
And then you subtract. You do subtract x, which is minus 0.9 repeating then, from this.
How do you subtract X?
I'm just rando doing that.
Oh.
So I said x is 0.9 repeating, then 10 times that is 9.9 repeating.
Oh, those are 2 different, right? Yeah.
And then I'm going to subtract x, which is subtracting 0.9 repeating. So I'm going to get 9x is 9, right? So x has to be 1. This is another dumber way. This has much less justification. this thing with geometric series is actually totally justified.
So would you do math if it's 0.9 repeating instead of 4?
No, that's funny. Cool, question, Steele?
X over X equals